this is where it starts to get fun. Simplifying expressions. We just talked about terminology, variables, terms, expressions, constants, coefficients. All those things start to come together now. What I'm going to do is show you an illustration, a visual, because so much of mathematics is related to geometry and the physical world. And so I'm going to show you what, first of all, 5 times 2 might look like as a visual. It might look like this. Very poor drawing, right? We have 5 here, and we have 2 here, right? But what I'm going to do is I'm going to take 5 times 2, and I'm going to add it to 3 times 2. Well, 3 times 2 might look like this. If we consider the visual. So we'd have 3 and 2. 3 that way, 2 that way. So that's multiplication as a visual. 5 times 2 and 3 times 2. We can see that in this little section here we have 10. If down in this section here we have 6. And together, if we added them, they would be 16. Well, since the widths of these little, rectangular figures are the same, right? They're both 2, right? This is 2 and this is 2. Couldn't we also look at this as just 8 by 2? Since these two terms are using the exact same number, wouldn't that give us the same thing if we did 8 times 2? Would those answers be the same? And we can see from the visual that they would be. 5 times 2 plus 3 times 2 is the same as 8 times 2. What we're going to look at now is, could this number be anything, right? As long as we changed it and so there was the same number, would that apply every time? Would 5 times 4 plus 3 times 4 equal 8 times 4? Would 5 times 10 plus 3 times 10 equal 8 times 10? No matter how wide we make these, no matter how many columns we have, no matter how wide we make those rectangles, it would always be 8 times however wide it is. So now we're going to relate that to some algebra. We're going to use that idea, but put it into, add some variables in there. So simplifying expressions is basically what we just did. It's taking an algebraic expression, like this thing that you see in front of you, and writing it in a simpler way. Well, we learned recently that these things are called coefficients. The coefficients of x are 5 and 3. Because the variables are identical, that's a key thing. If you have variables that are identical, you can combine the terms. You can combine them. And when the terms, remember we talked about terms, the things that are separated by the addition sign, when the terms have the exact same variables, we call them like terms. That's what these things are called. 5x and 3x are considered like terms because they have the same variables. And the way we combine them is we simply add the coefficients. That's how we combine. We add the coefficients. Coefficients. I spelled that wrong. Coefficients. There, that'll work. So 5x plus 3x would equal 8x. That's the simpler way to write it. That's the exact same thing we did right here, because these were the same, we could add the 5 and the 3. 5 times 2 plus 3 times 2 is 8 times 2. 5 times x plus 3 times x is the same as 8 times x. Okay, so that's the introduction. That's the idea of simplifying expressions by combining like terms. So, what if we have something like this? 3x plus 4 plus 7x plus 9. So, if we pause and examine this, this expression, and we are told to simplify it, what we want to do is look for any like terms. And again, they're the things that have the same variables. So what I see is a 3x here, a 7x here, and then we also have a 4 here and a 9 here. And those have the same variables because they don't have any variables. Those are the constant terms. So one of the little tools that we learned earlier, the properties, was the commutative property, where we can move stuff around as long as it's an addition sign. So that's what we're going to do. We're going to flip-flop these two terms around that addition sign right there, right? And whenever we move terms around in an expression, whatever sign is in front of it is always going to stick with that particular term. So wherever the 4 goes, that plus sign is going to go with it. So I'm going to leave the 3x where it is. I'm going to flip-flop these. I'm going to take this 7x, the plus sign is going to go with it. The 4, it's going to have that plus sign go with it. And then I'm going to leave the 9 where it is. And just move the middle two terms around simply so the like terms would be next to each other. Now we can add these two together because they are like terms, which is 10x. Right? 3x's plus 10x's is 10x's. And then we can add these two together. Plus 4 plus 9 is plus 13. And what we have now is a simplified expression. It happens to have two terms in it still, and that's okay. But one has an x, one has a 13. So we can't do anything more to simplify that. That is a completely simplified expression. All right. How about this one? So 3x minus 7 minus x. Okay. So when we talk about the commutative property of addition, we say we can switch things around addition signs. And I don't see any addition signs here. But we've talked about how we can change subtraction signs to be plus the negative or plus the opposite. You might even put parentheses around that just to sort of know that there's a negative that goes with that 7 now. We're going to do that here as well. So this is a little algebraic trick we can use to give us flexibility in our expression. It allows us to move stuff around. When I do that, I'm now able to move these two things around, the negative 7 and the negative x, so that the x's are next to each other. 3x plus negative x plus negative 7. Now I know it didn't start with parentheses in it, but they're just sort of there to, so we hold the negative with whatever came after it. Now we can combine these two terms, 3x plus negative x. Well, how do I do that? What does negative x mean? Off to the side. Side note. What does negative x mean? This goes back to that multiplicative identity. And in front of every variable that's just all by itself is a 1. Negative x and negative 1x are the same thing. If you see a variable all by itself, there is a 1 in front of it. There is one of them. So you might even rewrite it like that. You might even rewrite it as 3x plus negative 1x. And then when you're combining the coefficients, you're taking 3 minus 1, or 3 plus negative 1 to get 2x. Plus negative 7. We can bring that down and leave it as is. That's fine. But we can even clean it up a little bit more. We always like to, when we simplify things, to write it in the simplest form possible with the fewest symbols. And this thing right here is something that we did earlier in the problem to give us flexibility. But at the end, we like to switch it back if we have to. Adding the negative means the same thing as subtracting. If we add negative 7, it's the same thing as just subtracting 7. And putting it like that is the simplest, most efficient way to write it. So we would say this expression simplifies to be 2x minus 7. Finally, when it comes to simplifying expressions, we might see different variables or variables with exponents in them. So let's say we have 2x squared plus 3y minus 5x squared plus y. So again, we have terms with x squareds in them, here and here. We have terms with y's in them, here and here. I'm going to get them next to each other. So I'm going to flip-flop these two terms around. So I'm going to bring my 2x squared down. Now, in the previous problem, I showed you a way to flip-flop these by changing the subtraction into addition with the negative. Some people like that. Some people, it complicates things a little bit for. If you didn't quite get that, watch this. Negative 5x squared plus 3y. What happened there? What happened? Because the 5 had a minus in front of it, wherever we move this term, the minus has to stay in front of it. And this had a plus with the 3y, so the plus goes with the 3y. That's another way to apply this stuff without adding all the extra parentheses. Whichever way you find works for you is the way I want you to do it. Plus y comes down at the end. Now we have x squared terms here. 2 minus 5 is negative 3, x squared, plus 3y plus y. Remember, in front of any variable that's all by itself is a 1. It's an implied 1. 3 plus 1 is 4, positive 4. So we would simplify this to negative 3x squared plus 4y. And that is how we are going to be simplifying our expressions.